Okay, so this said to factor. Factor always means pull out the most that you have in common and write what's left over. So when I look at these, and you saw that these both had a 3 in it, and yes, you can pull a 3 out of both, but there's more than what these numbers had in common. There's also letters that they had in common, like this had 3 of the W's, this had 9 of the W's. So the most that they have the same, basically the amount that we could pull out or divide out of both of here, we can pull 3 of the W's out of both because they both have that many. Now I could pull more out of this one, but I can't pull more out of this one. So what you have to do is pull out the same amount. And so I would say that they both have 3 W's that I can pull out of here. Then I look at the X's. Well, the X's, the most that I could pull out of both of them at the same time, has to be the same amount, is 2 of them. So I'm going to pull 2 X's out of there. And then they don't both have any Y's in common. This has 4, but this doesn't have any. So this is the part, this is what we call the greatest common factor. This is the thing that they all have. They all have a 3, a multiple of 3. They all have a multiple of W to the third. They all have a multiple of X to the second. And so you pull out what's in common, and then you always write what's left over in the parentheses. And you should be able to multiply back through when you're done and land up here using the distributive property. You should be able to do that. You don't want to do that. That's not, our goal is to actually undo this problem and find out what was multiplied. But our visual to check ourselves should be that we can do that distribution and it would land back up here. So if I said, well, what times 3 would give me 15? That's a 5 here. What times W to the third multiplies to make W to the third? Well, nothing. If we put another W here, that would make that W to the fourth. And so we don't want that. We don't need any more W's. Same thing with the X to the second. We don't need any more X's to get to X to the second. And then to get up here to Y to the fourth, we don't have any Y's here, so we need Y to the fourth here so that it would land back up here. Another way to look at it is we could have written this whole thing as a division problem where we take 5W to the third, X to the second, and Y to the fourth, and we divide it by what we said was common, 3W3, X to the second. Well, when you do this, you end up with the 5. That takes care of that. The W to the 3's cancel out. 3 minus 3 is 0. I have 0 W's left. X to the second over X to the second. Subtract those exponents. You have 0 X's left. And then you have a Y to the fourth left on top. So you had a 5 Y to the fourth. And that's what we have here. Then we come over here and we go, okay, 3 times something gives me a positive 3. Well, 3 times a positive 1, basically, we can put that 1 there. Then we have W to the third times something gives me W to the ninth. Well, when it comes to exponents, you add them to get to there, so that'd be W to the sixth. And again, if we write this up here, 3W to the ninth, X to the ninth, over that common factor that we found in all of them, the 3's cancel out and give you a 1. The W's, you have, when you take 9 minus 3, that's 6. And the X's, 9 minus 2, that's 7. And you should be able to, again, 3 times 1 gives me 3. W to the third times W to the sixth gives me W to the ninth. And X to the second times X to the seventh meant adding exponents. Multiplying the base, but adding the exponents. So this was the factoring answer for that particular problem. This is broken down as far as it can, because you're always wanting to pull out the most. It's not enough to just pull out 3, because then we would still have been left with some W's and X's in there that they had in common. It wasn't enough to just pull out a single W and a single X, because they would have still had stuff in common with each other. We want to pull out as much as we can, and notice that what's left in these parentheses, 5Y to the fourth plus 1W to the sixth, X to the seventh, that these two terms just don't have anything else in common with each other. So we know that we did pull out the biggest amount possible.